For cs479 final project, team In Your Face, team members Anudari, Christopher, Michael, and Cebastien, we did a face recognition application with a mask or no mask. Our application uses various transfer learning models to detect faces with or without mask. The whole idea is to detect someone even though they're wearing a mask or not. It will use data from a webcam or video or just from a photo. The essential milestones of our project was that we had to run dataset through classification model with 2 labels and detect if a person has a mask or no mask. Then the dataset has to go through a pipeline into a specific model. If it detects it has a mask, then it will go to the masked face detection, and if it's not, it goes to the other model. And we had to improve the accuracy. At first it was many labels, so it was harder to improve our accuracy, and we had to start with a different data set, and then we added our own pictures. And this is the part that I did for this project. I used VGG19 transfer learning model. Also at the start, I used a different data set. It's classification, so there's only 2 labels. One is mask and the other one is no mask. Because of the number of labels, it was easier to train because the minimum is 50% if you guess. And I managed to get 97% at second or third try.
Hey everyone, my name's Cebastien, and I did the model with the face detection with mask algorithm. And basically for this, since there wasn't a long enough time period given for the project, I decided to go with a build model instead of making my own model. And I decided to use VGG face. VGG face is a multi-classifier algorithm, so it gets a lot harder than what Anudari did, which is basically a binary classification. At the beginning of the project, we basically decided we were gonna do celebrities at first, and I think we did like 17 celebrities, and it gets super lengthy because for each celebrity that's a definition of a class that goes into the class test label. And so that's basically BGG face model is a pre-trained model for face recognition developed by researchers at Oxford University. The input of VGG face is 224 by 224 by 3, and that becomes a struggle if you don't get that right. So like when you build the model, you have to be specific. You have to know what the input that the model receives in order to have like a successful rate of using that model. And some things that I found when using VGG face, it does not work when there's a lot of background in the back. It has to be focused on your face in order to have a high accuracy rate. So these are the results for my model, the confusion matrix. As you can see, it got 63 photos right for Anudari. It confused one of them to be Chris and another one to be Michael. For me, it got 74 right out of 74. For Chris, it got 70 out of 70. And for Michael, it got 49 out of 49. Okay, I'm gonna share my screen so I can give a live demo. Alright. Can you guys see me?
Yeah.
Alright, so this is a Michael's model which he'll introduce a little bit later. So his model was basically without recognize the face without a mask, and if I take the mask, then it thinks it's me, and then I'm able to move around, and it still detects me.
Mm-hmm.
Do I go this way? This way. So basically, at the beginning, when I ran this through the celebrities, it gave me a high accuracy, but it took forever to run because it had a lot of parameters. But basically, and it was taking a long time because the pictures with the celebrities had a lot of background and it wasn't really detecting the pure face. And then after Chris, he cropped the images to just the face. It gave a lot of better results and it ran a lot faster. Uh, so after we cropped the face just with the images, it gave a 99%, even 100, as you can see right there, 100% after that. And that's pretty much my model.
Cool. So I'm Michael, and for my part of the workflow, my model is taking Anudari input for the case of no mask on. So yeah, originally I used the celebrity data set of faces, and I had 17 classes. The results were terrible. It was overfitting, and so then I tried to use transfer learning and data augmentation, but my accuracy never went past 45%, I think. In our third sprint, we opted to use our team as a data set. And so I took 900 pictures of all of us, and half of them were with mask and the other half with that mask on. So having only 4 classes, it did wonders to my results. I went from I was running it with 100 epochs, which took at least 30 minutes, I think, to run. And now with only 10 epochs and like literally less than 2 minutes, I reach close to 100% accuracy. And I also used like Anudari VGG19, transfer learning, and data augmentation again. This time I adjusted some of the augmentation. I think I had a vertical flip that was not appropriate, so I kept it just horizontal flip, rotation, zoom, and contrast for my augmentation, and that worked pretty good. And as far as the references, I use TensorFlow docs a lot, and for this for all the parts of my project.
So I'm Chris, and my part was converging all 3 models into one part. I first started creating the dataset by cropping the images using CB2's DNN module, which stands for Deep Neural Network. It would first crop the pictures of all the face locations, then I would use that to save it in order for the rest of my group to train it on the face particulars. So once we have the cropped faces, we transfer that to the mask no mask model, and depending on the prediction, it would either be be input as a mask model or no mask model. Then the models will label and add a rectangular bounding box inside of the original images. If there are multiple images, each face would go to a particular model and be labeled as so. We tried multiple libraries to find face locations, and we found that DNN happened to be the best. But here are 4 test libraries. One of them is DNN, the other is MTCNN, and then we have the lesser models, facial recognition, which is based off of DLib, and hard cascade, which is another one of CV2. you can see that facial recognition and hard cascade cannot quite find the face if it is obstructed, while DNN and MTCNN has a better accuracy. But comparing those two, their face location changes very slightly, so the models sometimes can be inaccurate by so. Here we see the minute changes in the library causes a change in the labeling of the models. On the left side, DNN has correctly named me as Chris with a mask on, while MTCNN incorrectly names me as Cebastien, but with correct mask label. In conclusion, we would have been better off creating our own dataset, starting from the beginning, as opposed to using our celebrity dataset, in which we could...
Sorry to cut you off. I completely agree. I think we should have used our own data set and people from the classmates.
Yeah.
I think whoever suggested the part of using the other one, it wasn't that efficient.
It just complicated a lot of things.
Yeah.
With the power of Python and CV2, we were able to augment our faces more accurately and not introduce inaccuracies with background noise. And what we probably learned in the world of facial recognition, there are a lot of variants to account for, including, but not limited to, face angle, lighting, obtrusions, even age and surgery. That's where we thought maybe the celebrity faces kind of went wrong, since people change their face very often with hair color, surgery, glasses, no glasses, and stuff like that.
Okay.
Do I start?
Yeah.
Okay. You just
Excuse
got
me.
cut off.
So what?
You just got cut
What
off,
do you-
but continue.
I hear you cut off as well, so I don't know what you just said, but okay, I'll just.
So with the power of... Yeah.
Oh my god.
Thank you.
Yeah, thank you.